So initially I thought that I will just pick two of the problems that I worked on while at Flipkart with my academia counterparts. But then I thought that maybe it's more important if I tell you about how I, landed up in Flipkart in the data science role from being a researcher at Bell Labs, lost the sight of research for a while and then again went back to it. Right. So let's start there. So when I was in Bell Labs, or before that when I was in IISc, right? So the way you choose a problem, right, depends on what you want to get out of it. There is a set of problems which everyone knows is hard and important. Then there is a set of problems, that you can make a progress on and get published, generate IP, right? So that's the setting that you will find in a typical research lab or an academia. So back in those days, right? When I joined Flipkart, so it was completely different, right? So when I looked around, there were many small problems, and when you add them all up, right? None of the problems on their own are very hard, right? But the impact when you solve many of them together, right, is enormous, right? So for a moment, I thought that maybe I don't have to go back to research anymore to make impact in data science or in real world, right? Then there started appearing a series of problems which I thought is already a solved problem looking at the publications, etc. from the academia. But when I went to practice them, right, implement the solution and operate them day in and day out, I felt that it's far from being solved. So these two problems are two such examples, right? So in particular, what I'm going to talk about is, so we all understand that the social media is a important source of data, right? So if you want your business decisions to be driven by your customers' opinion, you better know how to tap into the social media and mine the data there. Now, the problem with, and Twitter is traditionally being the most open of all the social medias, right? It's hard to get Facebook posts and connections, but not so hard to get the Twitter connections and the Twitter posts, right? But the problem with Twitter is that it's extremely noisy. There are all sorts of people talking about all sorts of topic with a mix of sentiments, right? You are not really interested in the general chatter that goes on there, right? From your organization's perspective, you're perhaps interested only in a subset of topics, and that subset changes with time, right? Let's say that Flipkart launched a new product or a new feature, right? The manager there would like to know that how the users in Twitter are perceiving it, right? And Flipkart would launch something else tomorrow. They will take a new decision tomorrow. So the topic of interest changes over days, right? And but the pattern is very similar, right? So you first have to, that which topic you want to listen to. You want to filter out the tweets which belongs to that topic, throw away everything else. Of the tweets that you think belongs to the topic, you need to dashboard what is the general, the collective sentiment is looking like. So if you can solve these two problems and can do it over and over and over, you are adding value to the business, right? So this is where we began. So when you look at the literature or look at the product offerings, the APIs out there, you will feel like that the sentiment analysis for tweets is a solved problem, right? Retrieving tweets that belong to a topic is a solved problem, right? When you practice it, it's a whole different story. So that's what I will talk about when I present the sensing part of my talk, right? When you understand how to sense it, right? So how to figure out the topical tweets and their sentiments, the obvious next question is, can you shape them up? So if there are a lot of negativity going on and you have a crew of people who can respond to tweets, right, that comes to you, can you change the huge negative sentiment to something less negative or positive perhaps, right? So that's the second part of the talk, right? And the third one perhaps most likely I'm going to skip. So it's about the other academic engagements that we engaged ourselves into, and that also impacted how some customer facing constructs, right? So let's get on to the first part. So this is a joint work with folks from IIT Kharagpur, and what I'm going to present here is part of a paper that we got accepted and presented elsewhere, right? So to set up the problem, right? So as I described to you, so whoever is willing to listen to Twitter just wants two things, right? You want to tune into a topic of your interest, and you want to figure out what sentiment is there, right? Now, how do you build this radio? The traditional approach has been as follows. So your manager comes to your desk and tells you that, look, I want you to figure out that I launched Flipkart image search. Tell me what the folks in Twitter think about it. Then you have to think about that, all right, so what are the right keywords for Flipkart image search? There are hashtags, you can imagine up words, etc. But whatever you imagine up, either you are going to be extremely precise. If you are extremely precise, then you are going to leave out a lot of tweets, right, that indeed talk about this topic, but do not have those keywords in them, not all of them, right? Or you are going to be less precise and aim for a high recall. So you want to get all the tweets that talk about it with some lack of precision in them, right? So it's one of these two extremes, right? What an analyst would do is he will take this set, right, and manually label them. So does this tweet belong to the topic? +1. This tweet does not, -1, right? So he will prepare this label set. And he will do the same thing for sentiments, right? Is it positive? +1. Negative? -1, right? And once all the labeling is done, there is this thing known as classifiers in machine learning. You throw a classifier to your label data, and out comes your topic and sentiment classifier. But imagine that if you want to do it with agility, right? So where the topics are every day, you are getting a request for 30 topics. Can you really label 30 data sets in a day, right? So that's where the actual cost comes in, right? You cannot just employ enough people to gather so much label. So you have to think about that, so are there some changes that you can do to the algorithm so that the need for the label data is no longer there. So it's at least alleviated to it, right? So before I move on to the next slide, so so we tend to think that so there are these best sentiment analyzers out there which you can download and throw at any tweets, but it doesn't quite work that way. So depending on which topic the tweets belong to, the sentiment analyzer may or may not work and require a retraining. Right. So what we ended up doing is we changed this protocol a bit. So instead of asking for these huge labeled data sets for every topic, we said that specify the topic, right, with a pair of queries. So you know that Twitter has a open API through which you can search for tweets. So if you can specify the topic with a pair of such queries, then it's easy for you to gather the tweets as well, right? So of these two queries, the first one actually aims for high recall, right? It does not have a whole range of keywords in it, right? One or two which remotely are associated to the topic, right? But if a tweet matches it, you know that so nothing that does not belong to the topic, should match this query, right? And the second of the pair is a highly precise query. So it's the most precise keywords you can think of, right? So all you have to do is to specify these two, right, in the language that the Twitter search API lets you do, right? Take an example. So Flipkart image search, right? So the first query, the high recall one, you can set it as Flipkart or image search, right? So what happens is when you employ this query, give it to Twitter, it gets you this tweet as well, which does not really talk about a customer's perception to this feature, but talks about a blogger's myth that Flipkart organized around it. So this has no value if you want to figure out that how your customers are thinking. So you need to throw it away. So you make your second query, the Q plus, more precise by saying that get me everything that has Flipkart and image and search, but does not have the word blogger in it, right? You can be as imaginative as you can. But all you need is a pair of query to specify any topic. So no labeling, just a pair of queries. It's quick to iterate on as well, right? Second, you have to do something for the now that so you are not quite labeling, so I do not know that of the things that matches Q, how many of them really belong to the topic, right? So this there are a few other quantities that we ask for. So you have to tell me that of all the tweets that matched the first query Q, right? So what fraction of them you think roughly belongs to the topic, right? Of all the tweets that belong to the topic, what do you think of the fraction of positive versus negative sentiments? So we ask for a bunch of such quantities, 3 to be precise. And it so happens that the domain experts who actually carry out this analysis have a fair understanding of how these ratios are going to look like, right? And when you did the sensitivity analysis, right, things studying that what if you are off in your estimation of these numbers, it turned out that it's resistant to, so a bad case as well. Not terribly bad, but somewhat bad, right? So this is all the algorithm wants from you, right? So no standard algorithm out there, accepts this and gets you the tweet and sentiment analyzer. So you have to go and invent one, right? That's what the research part again resurfaced, right? So when you realize that you need to go back to the math and change the equation somewhere. I'm going to show you one such equation, but don't read anything into it. So all the message I wanted to convey is, so the standard stuff out there, right, does not work unless you modify it. And the modification is not very superficial as well, right? So you need to add or delete terms and change how things are optimized under the hood, right? And not just one, a couple such things, right? So when you do all this, right, and you, so we can skip this detail as well. So this talks about that if you had those new algorithms, right, how can you apply it to the tweets that you have, right? So so let's skip this as well. What happens is, so at the final stage, right, so you have done all those math, you have done the implementation, now it's time to test it against what's the best out there, right? So again, what we ended up doing is we ended up taking a few such topics as examples, right? Flipkart image search, which is kind of ambiguous. Then the Civil War movie. This is also something hard to classify, right? So when you search for civil wars, you get American civil wars and the other civil wars going on, as well as you get the movie, right? And the final one is this Chinese stock market crash. You get news about helicopter crash if you are not careful with your query, right? So the way, let's not think too much about what this what the thing AUROC etc. means. So the long story short is the second column there where we have written Ritter et al. So that's the best of the breed when you did this, right? Larger the number, better it is at classifying the sentiments and tweets, right? And it so turned out that with those modifications in the math and that code, you can actually beat that thing, right? And this actually in real life, right? So I stopped getting worried about how to get things labeled, right? So this helped me with that. Now once this, and so it so happened that this has wider applicability as well, right? So take this example. So when the terror attack in Paris was going on, there was this particular hashtag that was used for two different purposes, right? So there was a group of people who used this hashtag to offer shelter to the others. who were in need at that time. And then there was this larger group of people who used it to applaud humanity, right? So if you are in need, right, so you want to filter out the one that actually applauds humanity. So that is, you can come back and read later. So turned out that this hashtag disambiguation problem had not been solved earlier, and the same technique without any modification, uh, does better than what was out there before that, right? So a good piece of research that pushed the frontier in the research a bit, solved a problem that wasn't attempted before and made my life and others' life easier in practice, right? That's when the managers started seeing the values in getting back to academia and getting back to research. And they started asking questions about, okay, now that you can tell me that what's the sentiment out there, can you change it for me? So turned out that this was a far, far harder question, right? So sensing is one thing, but shaping requires intervention. Good. So the answer was that, look, I already run a customer care center where there are a bunch of people employed whose job is to, just read through the tweets that people tweet towards Flipkart handles, right, and respond to them. And if you respond, it's intuitive that if you respond to a message that carries a huge negativity early on, you are probably going to contain it. The measurement shows that as well, right? But the problem is, so running such a center on a bad day, so if you recall that the Big Billion Day in 2014 wasn't a particularly good day for us, right? So on a typical day, you would perhaps, back then, we used to see 3,000 tweets. On the Big Billion Day, we saw 80,000, right? And with a negative sentiment. Now, this customer care center was not really built with the bad day in mind, right? So it could not scale, it could not respond to all of them, right? And at least the social media sentiments remained negative for a while, right? So while we started working on this shaping problem, so we had to work under the assumption that you cannot augment the capacity of your customer care executives, right? So you are going to have n of them. You cannot add, get tenfold of them, right? Structure, right? So remember the knob at the center called LSCC. That's very hard to get into. So you get into there. So when you arrive and start taking part in the conversation, you are not there in LSCC or in the out component. So you all get queued up in this blue component called in, right? So you tweet to others, but they don't tweet back to you. So you are not quite important to them. So you get queued up there, right? When an important person who is in LSCC tweets back to you, so that's deemed important. Then you move to the component. Then there are people to whom everyone tweets to and they never tweet back. They're perhaps the most important of all, and they are the ones that are in the out component, right? So when you actually look at that, who were these users, you will find that not all of them are, the real users out there. You will see handles that are there. Their sole purpose is to promote Flipkart, right, in that audience. There are handles whose sole purpose is to, spread hate about it, right? They're not really the real customers. So we asked ourselves that where do these guys go, the real customers versus the others, right? So it so turned out that by keeping a snapshot of this graph as and when the tweets arrive to you, and figuring out where exactly each user lies, you get a sense of their importance, right? There are web services out there, the Cloud Score being an example, which tries to give you the sense of the importance of a person in the social media, right? So we figured that where they lie in the graph and what their cloud scores are very correlated, right? So although I'm not going to talk about how it really led to a prioritization logic, but the message to take home is just by figuring out where users lie in that conversation graph, you could rearrange, right? So when you have 80,000, you can figure out which one is the top 100 or top 200, right? And this we did not deploy. So from the experiments that we did, it turned out to well, so it was very promising, but we are yet to pilot it out there, right? So just wanted to mention that, so those two were two very specific examples. When you look at the entire e-commerce process and the entire e-commerce funnel, there are many opportunities, so right starting from what to procure, where to stock them, right? Where to ship things from, right? So that you are abiding by the SLAs, right? To how you surface them up to the customers when they come to the app or Flipkart.com. To figure out that when they write a product review or a service review, how to aggregate them, how to rank them. All of them turned out to be, affect customers' decision of buying or, converting, right? And you really have to deal with them carefully. It's not very easy to mine a product review, right? It's not very easy to help a user based on the product reviews to help him decide between two products. So we did a bunch of other works along these lines. Again, so every work that I'm showing you here are done with the real academia partners out there, either at IISc or at Kharagpur or at CMU, and they resulted into a tangible paper or